in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state champions, the North Shore Mathletes.
It was just too technical. Hello, pre-calc students. Here's a video on limits. Your first video on limits. Okay, so the primary goal of this video is that you're able to evaluate limits both by the equations, so algebraically, without using a graph, and also to be able to understand your answer by a graph. So, you'll be able to use a calculator for these problems, so you should be able to understand how to evaluate a limit graphically, although it's usually easier and faster to do it algebraically. You should see how they work together. All right, so we'll do one or maybe two examples here and go from there. Let's see if I can get a little closer. All right. So here's one problem. Here's the way you would see it. Okay, so evaluate the following. The limit as x approaches -2 of 4 over x plus 8 over x squared over 1 minus 4 over x squared. All right? So what this means, sometimes you'll see brackets or parentheses around this expression. Doesn't really matter. All right? So what this is asking you to do is, it's saying, okay, visually speaking, the graph of this function, y equals this expression, if you picture that graph, even though you don't know what it looks like, if you track the x-coordinate as it approaches a value of -2, all right, from either direction on the graph, as x is approaching a value of -2, what is the y value approaching? What is it getting very close to? All right? It turns out there is no function value at that point. F of -2 does not exist. If you plugged in -2 into that function for x, you'd be dividing by 0, right? If you plug in -2, you'd get 4 over 4 is 1, 1 minus 1 is 0. So in this function, f of -2 does not exist. But that does not mean the limit does not exist, okay? The limit is asking you what's happening as x is getting very close to that point, not exactly at that point. All right, so here's the algebra you should know how to do first, and then we'll check the graph just to make sure you understand this visually. All right? So it is a good idea to just check and see if you can plug this number in, because if you can plug this number in and get a real number for y, then that's just your answer, okay? But that usually doesn't happen, all right? So what we're going to do is, like you know how to do from the recent review we just did, if you multiply top and bottom by x squared, you're multiplying the entire expression by a fancy version of 1, we now end up with, we'll just kind of carry down the limit, all right? We now end up with 4 over x times x squared would be 4x squared over x, which is 4x. 8 over x squared times x squared would be 8x squared over x squared, which is just 8. The denominator, 1 times x squared is x squared, and then 4 over x squared times x squared is 4x squared over x squared, which is just -4. All right? So now we have a simpler expression to work with. All right? From this point, we still can't plug in -2, right? Because we would get 4 minus 4 or 0, but we can factor. If we can factor, we always want to do that. That's always going to be an important skill to use when evaluating a limit by hand, okay? Not all of the problems involve factoring, but oftentimes they do. The numerator factors into 4 times x plus 2. The denominator, of course, factors into x plus 2 times x minus 2. So x plus 2 over x plus 2, common factors, numerator and denominator, cancel out. We're left now with the limit as x approaches -2 of the expression 4 over x minus 2. So we've simplified the expression to something where now we can plug in -2. Now, if you plug in -2 for x, we get 4 divided by -2 minus 2, which is 4 divided by -4, which is -1. All right? So the answer to this problem is -1. This means that on the graph, when we check our graph, as x approaches -2, y is going to be approaching -1. Okay, so now to remind you about rational functions, you know, this graph is going to look like this. I took the liberty of already typing that in, just to show you, y equals, I typed it in there, all right, the original function. So if you type that in, you see the graph, it looks like that, right? Where x is -2, it looks like there is a point for y, but if we check the table, you see that where x is -2, we have an error, right? That's because there's a hole at that point. Okay, where x is -2, there's a hole. But the limit does exist. As x approaches -2, you're right around here. Y is approaching some value just under the x-axis. It turns out to be -1. All right, so we can't see it exactly on the graph, but we can see that our answer does make sense. Where x is approaching -2, so you're kind of out in this area, y is approaching some value that is negative, right? Now, if we wanted to be especially careful, here's a quick way to kind of sort of cheat. Change the table set to the ask feature. All right, now go to the table. It looks empty, right? Well, you can plug in numbers very close to -2. If you plugged in -2, you wouldn't be able to do it. You would just get an error. All right, but if you plug in like -2.001, you get a number that is about -1. And from the other side, if you plug in a number like -1.99, just to double check, another number very close to -2, we get something that's just under -1, right? So from either direction, the y values seem to be approaching -1. They're very close to -1, even though at -2, there's an error, okay? So understanding the limit both by the graph and by the table and by the equation, doing it algebraically is the goal of the unit on limits, all right? I think, again, it's easiest to just do it algebraically, just by doing things you're used to, factoring, canceling, and now plugging in. But it's important that you understand how this makes sense visually also. Video is 7 minutes long. All right, so